Hello, today I'm gonna solve regular expression matching. Let's read the problem. Given an input string S and a parent P, implement the regular expression matching with the support for dot and asterisk characters. Dot matches anything a character, and asterisk matches zero or more of the preceding element. The matching should cover the entire input string, not partial. And note that S could be empty and contains only lowercase letters A to Z, and P could be empty and contains only lowercase letters A to Z and characters like dot or asterisk. Okay, let's see the example. S is AA and the pattern is A, so the output would be false because the parent doesn't match the entire string of S. In the second example, the output is true because the asterisk could repeat the character A twice, matching the string S. The example 3 is also true because the dot character matches anything a character, and it could be repeated by asterisk any longer than any combination of string, because the character C could be removed by asterisk repeating 0 times. Example 5 is a little bit complex, but we could check the parent in detail. The first MISS is matched by the parent MIS asterisk, repeating S character 2 times. And the next ISS is also matched by IS asterisk. But we could see that the next I character could not be matched by the next parent characters, so the output is false. We could easily do this pattern matching intuitively. So let's think about the procedure doing this in our program. In the first example, we can think about the decision of true and false. We can suppose the string SMP and the iterator INJ moving from the starting point to the end of the strings when the parent characters matches with string characters. When this pattern matching process is over, we are going to check the INJ if they reach the end of the string. Both INJ reaches the end of the string, we could see it matched completely, so it returns true. But one of INJ reaches the end of the string first. It's not matched completely, so we should return false. Okay, let's see the second example containing asterisk. First, we are going to match the character A in both S and P, and it moves the index I to the next position. At this point, we don't move J index to the next point, because we could check the asterisk existing in next place, and then we could match the next A character one more time, and then we move INJ to the end of the string. Actually, we don't know how many times to repeat character A with asterisk, so we have to check all possible cases in our code. So if there is one of those cases putting INJ to the end of the string at the same time, we could think that the parent is matched completely. Let's see the example 3. It's almost the same as example 2 because that character could match any characters, and the asterisk repeat that character more than 0 times. So we could send the INJ to the end of the strings, so the return value is true. Okay, let's see my solution. I implemented the matched function, which is called recursively, with INJ index parameters. When the match function is called, you could see that the INJ index are increased by 1 or 2, selectively based on conditions. I also used the DB table, which is a two-dimensional array storing the temporary result. I mean that the smaller problems result are stored in DB table to avoid the duplication of calling recursive function. Index INJ are the key of DB table, storing the result of the string and the pattern, which would be the partial string of SMP, starting from INJ respectively. So as you can see in the diagram, the partial string S and the partial string pattern represented by INJ could be matched or not. The result is stored in DP INJ, and this result is used again to get the result of a bigger string matching. That's the principle of dynamic programming. Okay, let's see the code again. I use the DB table to store the smaller problem's results. DB table is initialized to -1 at the beginning, so if it has the value different from the -1, we return the value immediately without progressing the function to avoid the duplicated calculation, providing much faster performance. DB table is stored at every return statement just before returning the result, with the current ij as a key. This condition is checking index I reaches the end of the string. If j also reaches the end of the string, which is the end of the parent string. In this case, the parent is completely matches the string, so we should return true. If the parent string is remaining, we need to check the next string. It could be the asterisk. For example, the string s is AA and the parent is AAA asterisk. In this case, AA is matched first, but in parent string the A asterisk is remaining. But in this case, the asterisk could nullify the character A, so the return value should be true. To do that, we should call the matched function with j increased by 2. It will satisfy the previous condition. In else case, we should return false. J reaches the end of parent, while string s is remaining. It should return false. And this part is a character matching algorithm. At first, we should compare two characters from string s and p. If two characters are matched, we should check if the next character is asterisk or not. If the next character is not asterisk, we should call the recursive function with I plus 1 and j plus 1, because the pattern character could not be repeated, so we can just compare the next characters. In else case, we should combine two cases, I plus 1, j and I, j plus 2. What do these two represent? The first case means it repeats 1 times, and second case means 0 times repeat. You could better understand with the diagram. J plus 2 means the skipping asterisk in parent string without repeating anymore. So with these two combinations, we can represent any number of times repetition of characters, which is very intuitive using recursive function. And if characters are not matched, we also need to check the next character is asterisk. In this case, we just call the recursive function with I, j plus 2, because the current character is not matched, so we need to skip current character in pattern string, which means the 0 times repetition. If next string is not asterisk, this pattern matching failed. Okay, the runtime of this code is 4 milliseconds, which is faster than 93.10%. Okay, before I wrap up this video, I want to introduce the Java solution in LeetCode.com for this problem. It's almost the same as my solution, but this code is more shorter and clean than my code, but basic principle is the same. This recursive function does not using memoization, so the performance is not good. So I also added the memoization technique in this code, and we could see how much performance has been improved with the memoization technique by removing the duplications of calculating sub-problems, which is the same performance of dynamic programming solution using DB table and for loop to fill the dynamic table in bottom-up direction. Okay, thank you for watching. See you next time. Bye bye.